Here we have a physics question. So a mass of 5 kg stretches a spring 10 centimeters. The mass is acted on by an external force, 10 sine t over 2 Newton, and moves in a medium that imparts a viscous force of 2 Newton when the speed of the mass is 4 centimeters per second. All right, well, if the mass is set in motion from its equilibrium position with an initial velocity of 3 centimeters per second, formulate the initial value problem describing the motion of the mass. So what is good is that we do not have to solve the problem, right? So just to formulate it. Now, the general formula is that m y double prime plus gamma y prime plus k y equals f of t. So here m is the mass, gamma describes the viscous resistance, k is the Hooke's law for the spring, and F is the external force. So in our case, we are explicitly given M is 5 kg, and we are explicitly given F, it is 10 times sine of t over 2. Well, the rest we have to figure out. So first, how do we find K? So K comes from Hooke's law. Well, Hooke's law, according to Hooke's law, the force the force of the spring is proportional to the displacement. So it is K times the displacement, so L. So on the other hand, the force here is just the weight of this mass, right? So which is Gm. So now balancing the forces, we get the equation Gm equals KL. And from here, we see that K equals is Gm over L. Well, this was actually in the lecture, so I'm just repeating the same argument. Now, let us find K. So K is Gm over L. So G is acceleration due to gravity, is 9.8. So let me write meters per second square, times M, the mass is 5 kg, divided by L, and L is 10 centimeters. Well, centimeters, well, we should convert everything to the same units. So here, usually the units are meters, so we should convert 10 centimeters to meters, and this is 0.1 meter, right? So now K can be found. K is 9.8 times 5 divided by 0.1, so which is what is 98 times 5. Well, this is what is 980 over 2. It's 490. So K is 490. So let me write it here, 490. And then we need to find gamma. So gamma is this viscous force. Now let me write it, this viscous force F. Well, its magnitude should be some coefficient of proportionality, which is gamma, times the magnitude of the speed, because the viscous force is proportional to the speed of the motion. So in other words, from here we see that gamma is the magnitude of the viscous force divided the magnitude of the speed vector, and the viscous force is 2 newtons, and the speed vector is 4 centimeters per second. And again, we have centimeters, so we should convert it to meters, of course. So this is 2 newtons divided by 0.04 meters per second. Right, 4 centimeters is 0.04 meters, and this is 50. So now this is 50. Okay, now we have written down the differential equation. So this is 5 y double prime plus 50 y prime plus 490 y equals 10 sine t over 2. This is the differential equation. I guess you could cancel it by 5 or something, but it's not really important. So now we also should be given the initial condition. So the initial condition is y of 0 equals So if the mass is set in motion from its equilibrium position, so the initial position is the equilibrium position. So y of 0 is 0, and y prime of 0 is initial velocity of 3 centimeters per second is 0.03 meters per second. So this is the final answer.